Now look at some cases which have a complex alkyl substituent. So first thing is, I have taken this chain because in this chain the triple bond and the double bond both are present. So you cannot move your chain this way and leave out the double bond. Functional groups, double bonds, triple bonds, everything should come into the main parent chain. So the main parent chain will be from here till here. So now on this chain I have numbered from this side because the double bond must get the lowest number, but your compound will be an ine. We've discussed this before. If there are double bond and triple bond both are present on the chain, then the numbering is done from the double bond, that is the double bond is given the lowest number and your compound's name ends with ine. Now on this chain, at place 3 there is another chain, and on this chain there is this branching which has come out of the chain. So there are 3 carbon atoms in this chain. Supposing this was not present, then I'll just say at place 3 is a propyl group present. So I would have written 3 propyl and then about this hept, 1 ene, 4 ine. But on propyl there is also another chain, another group which is outside the chain. Number the chain from this point, 1, 2, 3. So at place 2 is a methyl group. So I have to mention at place 2 is the methyl group, otherwise it is a propyl, and this is present at place 3. Again, at place 3 without this is a propyl group direct. But what is on the propyl group? At place 2 methyl. So place 3 there is a 2 methyl propyl. Hept is the chain, hept. At place 1 is ene, at place 4 is ine. So the compound becomes this. See the next one. See the next one. In this there are groups which are outside the chain, CH3 at place 3. This is the main chain which contains 2 double bonds. I am counting from here 1, 2, 3, 4, 5, 6. 6 is the number of carbon atoms in the longest chain. Then this is the branching which is outside. I cannot move this way because in doing that double bond will go out. I cannot rule out in the parent chain, even if it becomes smaller, you have to keep the functional groups inside the chain. So now looking at this chain, again there are groups which are outside the chain. There are 3 carbon atoms, so it is propyl. If nothing was attached, it would have been 3 propyl, 3 methyl. But at the moment on the propyl group, there are groups which are outside. So we will have to tell what are those groups. At place 1, 2 methyl group. At place 2, another methyl group. So I'll say I have started with this 3 methyl, this one 3 methyl this. On the propyl, which is also present at place 3, 3. On this propyl group 1, 1, 2, trimethyl. Chain is hex, diene, 1, 5, and one is at place 1, the other ene is at place 5. So diene. So you'll have to write down everything and find out what is on this chain and what are the groups which are present on the chain. Now see a little change. Like if there is one cyanide group attached here which is called nitrile, I'll put it in the chain, 1, 2, 3 and 4 carbon atoms in this chain. So it becomes butane nitrile. Butane nitrile. It is at place 1, so you can write butane 1 nitrile or only nitrile. Now in this case there are 3 nitrile groups attached here. If there are 3 nitrile groups attached, more than 2, we are looking at more than 2. If there were 2, dinitrile can also be written, but if there are 3 nitrile groups attached here, then we will not include this carbon atom in the chain. And the chain starts from CH2. So now the chain is for 5 carbon atoms, so it is pent. At place 1 is 1 nitrile, at place 2, at place 4. it will now be called tricarbonitriles. So if more than 2 same functional groups are present, then the name changes. Like in this case, here there are 2 COOH attached. In that case, I will count from here 1, 2, 3, 4 and 5 carbon atoms in this chain. So it is a pent. At place 1 and 4 are oic acid. So I'll say pent 1, 4 dioic acid. But supposing in this case there was one more COOH attached. This was one more COOH attached. So in that case, I will not count these in it, and it will now become a chain with 3 carbon atoms. 1, 2 and 3. So when the chain is of 3 carbon atoms, we will say from at what places are COOH present. So COOH, first one is present at place 1, second at place 2, third at place 3. So we'll say it is 1, 2, 3 prop, 1, 2, 3 tricarboxylic acid. So the names change a little when more than 2 same functional groups are present on a chain.